everyone. Today, let's solve this Amazon interview question. This is copy list with random pointer. Let's read this problem statement together. A linked list of length n is given such that each node contains an additional random pointer which could point to any node in the list or null. Construct a deep copy of the list. The deep copy should consist of exactly n brand nodes where each new node has its value set to the value of its corresponding original node. Both the nest and random pointer of the new nodes should point to new nodes in the copied list such that the pointers in the original list and copied list represent the same list state. None of the pointers in the new list should point to the nodes in the original list. For example, if there are two nodes x and y in the original list where x.random points to y, then for the corresponding two nodes x and y in the copied list, x.random points to y. Return the head of the copied linked list. The linked list is represented in the input output as a list of n nodes. Each node is represented as a pair of val, which is a value of the node, and random index, where value is the integer representing node.val, and random index the index of the node. It ranges from 0 to n-1 that the random pointer points to, or null if it does not point to any node. Your code will only be given the head of the original linked list. As you can see in this example here, you can see that the linked list of both input and the output are the same because it is just a deep copy as it is given here. The val node.val should be the same for each node, and the pointers nest and random should point to the same nodes as it is in the original list. And here there are two other examples, and I'm gonna start coding now for this one. And here this is the definition of a node. Let me talk about the structure of the node here. Basically, this represents an individual element in the linked list where each node has three main components. As you can see here, int val, this stores the value of the node. It's the primary data associated with the node. And the nest one, node next, this is a reference to the nest node in the linked list. It establishes the sequential order of the nodes. And the node random, this is a reference to any node in the list or null. Unlike nest, the random pointer can point to any node in the list, even back to itself or null. And also the nest node can be null too, especially for the last one. So let me start coding now. So to code this, I want to talk about certain things. Yeah, so basically, to solve this problem of creating a deep copy of a linked list with random pointers, we need to consider a few things. All nodes should be duplicated properly. That is, every new node must mirror the value of the original node, and the relationships, both nest and the random pointers in the new list, should accurately replicate the counterparts in the original list, and also the new nodes must be entirely independent of the original nodes. And here we need to be very careful that when creating the deep copy in a single pass, we likely run into issues where pointers, especially the random pointers, they can't be resolved because some target nodes may not have been created yet. So this could lead to divide the process or this into distinct steps. So yeah, because of this, we are dividing the process into distinct steps. The step one would be duplicate nodes and insert them. We need to create new nodes corresponding to the original ones. Placing the new nodes directly after their originals ensure easy identification of which original node corresponds to which new node. Adding the need for additional data structures like hash maps to map original nodes to their copies. So what happens if we skip this step? Without a clear mapping between original nodes and their copies, assigning random pointers becomes complex. We need an additional data structure to store the mapping, which increases memory usage. And the second step would be assign random pointers. Why do we need that? Why do we have to assign random pointers? Because the random pointer links are critical and can't be skipped. Since new nodes are placed immediately after the originals, the random pointer can be resolved using the following logic. If the original node's random pointer points to A, so you can see, yeah, I'm going to use this later for the code. If the original node's random pointer points to A, its duplicate's random pointer should point to A dot nest, the duplicate of A. So what happens if we skip this? The deep copy won't have the correct random relationship. It would just be a copy of the sequence and not a true deep copy. And the third step would be separating the two lists. So once the deep copy is fully formed, we need to detach it from the original list to ensure the two are independent. This ensures the deep copy has no residual dependency on the original. The two lists must remain entangled, sharing some structure. Modifying one list would inadvertently affect the other if we skip this step. So there are other alternative approaches and choices too. So I think I would talk about it after the code, and let me start coding right now. So here, Okay, I think there is an extra parenthesis. Let me run now. Okay, I'm sorry, I don't know where this one came from. I need the name, method name. Yeah, it's just I didn't notice that, so yeah, I don't know why this is here. Yeah, the input is the head. So as you can see, the test results are accepted, and I'm gonna submit this code to see, to look at the results. Yes, it has a good runtime, 0 milliseconds, and that's really good. And okay, so now I'm gonna try to explain this. I'm gonna walk through this code. I have the linked list ready here for the first example. So I think I would go with the smaller one. Let's say we have the smaller linked list where like it has We would need a text box here. Let's say we have a linked list 1, 2, 3, and here and the random pointer of the first node is gonna be pointing to the third one. It's pointing to 3, the third one. So I'm gonna say I'm just going to move this little up so that it's easy for me to show the pointers here. And the random of the second pointer, it is going to point at this one, the first node. Okay, maybe I think I would just so first we are gonna say what is the head. What is the head here? The head is going to be 1 plus 1 points to 2 points to 3. So that is going to be the input, and we don't have the new list yet. And so the step 1 would be create a new node with value 1 and insert after 1. So now the list is going to be 1 is going to point to 1 is going to point to 2. Maybe we can just change this color or some color. And then next we are going to do the same for the second node. We are going to create a new second node and insert after 2. So now because we duplicated and inserted right after the original node, it's going to be like this. And then we are going to repeat the same step for the third node. Now this is what we are going to see. You can see this in the code here, where it's the current would be the head. So and the current, so head is going to be one points to 2 points to 3, and so current is not null. So as you can see in the while loop, we are going to keep creating the new nodes with the same value of the current and then pointers. As you can see, the current dot nest, so current is going to be 1, and what happened, where did it go? Here, yeah. So I'm going to bring this here, and current is going to be, I'm going to duplicate this in the second slide, and as you can see, current is going to be as you can see the code. Yeah, we need another text box to explain this. So it's very difficult for me to keep dragging both the windows. So I'm going to paste it here in the text box. Maybe we need a new text box here. Yes, here as you can see, the first we are creating the new node. Yes, we have, I'm skipping that step because I've already created all the 3 nodes. And here I think I'm gonna take these so now as we can see that new node.nest is equal to current.nest. So as you can see, the current is the head, which is the first node right now. So the head is pointing to the first node currently. So current is going to be this, the first node, this is the current. So the new node, we are gonna create a new node, and it has the same value, it is identical to the first node. And here so the current is gonna be the first node, let's say node 1 at this time. And so here we have duplicated the first node, and the new node dot nest, this is the new node, and the nest, yeah, basically now currently this one points to, oh I need those things. So this one points to third one, and the third one points to 2. Oh no. I need these arrows. Okay, I have these arrows here, and I just trying to put these. So the first node is pointing to the third one, the random of the first one is pointing to the third one, and the random of the second one is pointing to the first one. And the random of the third one is pointing to the second one. And now we have so according to this code, where's the code? Okay, I don't know where the code is, I just copied and pasted it here. Looks like I need to create another text box to copy the code again. Let me move this text box, and let me copy the first step here. Yes, now the head is pointing to the first node, which is node with a value 1 in it. And so that is going to be the current node. And so here we created the new node identical to the first node, and the new node's nest is going to be the current's nest. So the current nest, this is the current one. So this is the current one. The new node's nest is going to be the current node nest. So the current node nest, it points to 2. Let me put the nest to, okay. 1 points to 2, and 2 points to 3. Actually, it points right here. So here I want to say that the current node's nest is so the new node is this current nest. The current nest is this one. So the new node nest is also gonna be the same thing. Copy and paste, and I'm going to put the pointer. And then what we have, the current nest becomes the new node. So now we get to change this. Take this and put it here. And then so where are we now? We put the current nest as a new node. So current is equal to new node dot nest. So now the current changes. So current becomes the duplicate first node, which is this one. So I'm just gonna say D1 just to show that this is the duplicated one. And then now we are gonna again current is not null, so current is a D1, right? Yes, and it is not null, so we are gonna say new. We are gonna create another new node, and currents val. Sorry, the current is not going to be the new node, it's new node's nest. So new node's nest is pointing to this one. So I'm sorry, it's not the current is not the duplicate first node. The current is going to be the second node here. And now we are inside this while loop. We are creating another a new node with the current's value. So we are just duplicating this one here. And so again I'm just gonna say that wait, this is coming with from here, where I don't know where this one goes. Yes, say D to show that this is the duplicated second node. And now we have this new node's nest, and that is going to be the current's nest. So the current's nest is what is the current's nest is the third node. So the same thing, duplicated nest is also the third node. And then Current's nest is going to be the new node. Yes, so here we have current's nest. It's going to be this new node, and current is going to be the new node's nest. So this is new node's nest is 3. So now the current is going to be the third node. And when current is the third node, it's not null yet, and we are creating another, we are duplicating the third node. And I'm gonna put this one right here. Let me try to move this a little bit. Okay, let it be like that. So here I'm gonna say D3 to say that this is a duplicate of the third node. And now after creating this new node, I'm going to say the new node's nest is going to be the current's nest. Current is third node. Third node's nest is going to be, we know that the third node's nest is null. Yes. So same thing happens. So this is null too. So, and then okay, so here we are. Yes, let me check the code now. Now we are going to go to the second step, and I'm going to make another copy of the slide. So here we are going to work on the second step. This is where we assign random pointers to the new nodes. As you can see, all the random pointers in the new nodes are null. So first we are going to see that where is current pointing to. Current is the head, and so this is where the current is pointing to, and current dot random, it's not null, it's pointing to 3. So current dot nest dot random, that's gonna be the current dot random dot nest. So current dot random dot nest. Yeah. So current dot nest dot random is going to be the node D1, and current dot nest is the D1. So D1 dot random is equal to current dot random. Current's random is pointing to node 3. So yeah, it's not even pointing to D3, it's pointing to 3. So 3, node 3 dot nest. So what is node 3 dot nest is equal to null, right? Yes. No, actually node 3, yeah, in the previous step I did a mistake there. Node 3's nest is pointing to this one. That's what it's pointing to. And so that is node 3's nest is pointing to D3. Yes, so that is D3. So D1's random is pointing to D3. Now again let's go through the code, and here current is, now what's the current we have? Where are we? Now here we are in this step of the code. Current is equal to current is 1. In the initially when we started, current was the node 1. Current points to node 1. So node 1's dot nest, that is going to be D1. The duplicate node 1 dot nest, that's nest, and that is going to be 2, node 2. And now that's the current, and current is not null, and current dot random, what is random? Node 2's random, that points to node 1. So current dot nest dot random, that's gonna be current. What is the current we have is node 2. Yeah, node 2 nest. the nest for node 2 is gonna be duplicate d2. So d2 dot random is equal to current dot random node 2's random. Node 2's random is pointing to node 1. Node 1's dot nest. So d2's random is going to be node 1's nest, which is this one, d1. And now the current node is going to be, so the current is a node 2. So sorry, now we are in this step, we are assigning the current. So the current is going to be node 2 dot next, which is going to be node 2's dot nest is d2 dot nest. So d2 dot nest is going to be 3, node 3. So node 3 is the current one, and so the current is node 3, and so node 3 dot nest dot random. So node 3 dot nest dot random, that would be node 3 dot nest. It's not null, we change that. Node 3's nest points to d3. So d3 dot random so d3 dot random is equal to current.random.nest. So current is going to be node3 node3's.random.nest, which is going to be node3's.random. What is node3's random? Points to 2, node 2. Node 2's next. What is node 2's next? It's point to D2. So D3 is random points to D2. Now we have the original list where the random pointers are unchanged, and the duplicate list where the random pointers are correctly set. Now the third step would be to separate the list. The original and the duplicate list are interleaved, so we need to separate them. So let me duplicate this page, and here we are going to work on the third step. Let me copy the code for the third step. Here new head is equal to head.nest. So here we need to detach the duplicate nodes from the original nodes. So we are gonna make some changes to the pointers, the nest pointers, because the nest pointers are those are pointing to the duplicate ones. So first we are gonna say the new head is equal to node head.nest. So head is node 1, we know that. So if you say head.nest, it's going to be node1.nest, and so that is the new head, and current is going to be the node 1. And while current is not null, new node is equal to current.nest. New node is equal to be node1.nest, which is going to be D1, and node1.nest is equal to D1.nest. Yeah, that's convenient because D1.nest is going to be node 2. So let's make the changes. Node1.nest is equal to be D1, not D1, it's going to be D1.nest, so which is going to be node 2. And then what else we have? Here we have Yeah, here we have current.nest. So we know that the current is node 1. Node 1, so if, new node dot nest, what is new dot not nest is, new node is d1, so d1 dot nest, that's not null, that's pointing to node 2. So d1 dot nest is pointing to node 2 actually, so is equal to, we are assigning new node is actually d1. So current is node 1, node 1 dot next. So we are assigning node 1 dot next is equal to new node is d1 dot next. So node 1 dot next is equal to d1 dot next, which is gonna be node 2, and then after that we are checking if the new node, which is d1 dot next, is not null, and that is the case. So we are saying d1 dot nest is equal to d1 dot nest dot nest. So d1 dot nest is going to be node 2. Node 2 dot nest is going to be d2. So d1 dot nest is not node 2, it's d2 actually now at this time. And now we are making sure, we are saying we are resetting the current. So current is equal to current node nest. So currently the current is node 1. So node 1 dot nest is going to be d1. Not d1, we changed it already, it's going to be node 2. So current is going to be node 2, and now we are creating this new node, which is going to be current.nest. So we are here, let's keep this there. So that's going to be node2.nest, and that is going to be d2. And now we are in this, the moves to the nest tab, and here current.nest, so it's going to be node2.nest. It's equal to, the new node is d2 dot nest. So node2's.nest is equal to not d2, it's d2.nest, which is node 3. Instead of the arrow, I'm just gonna put a what can I put there? I'm just gonna put plus sign there, couple of plexes. So here, if or I just can put this one like this. So here the new node is, we know the new node is D2. So D2 d2.next, obviously that's not gonna be null, so d2.next is actually node 3, and node 3 d2.next is node 3. Yes, so we are gonna say d2.next is equal to d2.next. So that's gonna be d2.next d3.next is pointing to d3. Yeah, d2.next is node 3, which .next is d3. So we are gonna take this and put it there. Now we are gonna reassign the current. What the current is gonna be? The current is gonna be current.next. So current is node 2.next, and what is that? That's node 3. Now we are in the final iteration. Now again, let's go and now we are here. We check the while loop, current is not null, so we are right here. New node is equal to current.next, which is node 3.next, which is gonna be null, and yeah, actually node 3.next is not null. Currently it's pointing to d3, so it's pointing to d3, and current.next is equal to current is node 3. Node 3.next is equal to new node.next. So the new node is gonna be d3.next, which is actually null, and So the new node not next. New node is D3. At D3.next is null, so we don't have to do this step. And then we are going to assign the current is equal to node 3.next, which is going to be which is D3. Now when we come and check if current is not null, yes, current is not null, and we are going to say new node is equal to current.nest, so d3.nest, which is going to be null. We are here. So the iteration ends here, and I think we have what we need. And now let me check if we are in the yeah, now I think we detached it. Let me see if when I try to take this one, yes, I can see that the nest is connected to only this, and D1 we have detached both the list. Let me try to take this there. Yes, you can see none of these arrows point to this one. Okay, there are other alternative approaches and choices. Sorry, I couldn't speak properly because it's getting late. We can use option 1, which is like we have different options. One of it is using a hash map. We can use a hash map original node, where the original node points to the copied node, and to store the mapping between the original nodes and their copies, and traverse the original list, creating the copies and populating the hash map, and traverse the list again to assign random pointers using the hash map. So the advantage here is it's straightforward, conceptually straightforward, as the mapping directly solves the problem of resolving random pointers. The disadvantage here is it requires extra memory for the hash map, and two passes through the list are needed, plus additional work for hash map operations. And the other option would be using recursive deep copy. Here the approach is to use recursion to clone each node along with its nest and random pointers. The pros are, the advantage here is it's elegant and concise and it works well for small lists, and the disadvantage here is for large lists the recursion depth could exceed the stack limit, leading to a stack overflow, and it is more complex to implement without extra memory, that is to track the visited nodes. And that's why the chosen approach minimizes both time and space complexity. It avoids the extra memory usage of a hash map. Alternatives like hash maps require O of n space. By placing duplicates next to their originals, the random pointer resolution becomes a local operation, avoiding additional traversals or lookups. The three-step process ensures clarity and separation of concerns, making it easier to debug and verify correctness. And thank you for watching. I'll see you in the next video.